day to Doctor and everyone else. So I'm Aurelia, and I'm gonna introduce you to our group. I'm Lukman, Chinchingla, and also Farisha. Today we will be presenting about our 3D modeling project, which is also a table fan. So as an introduction, this project will be exploring about the reconstruction of the table fan and also to demonstrate our AutoCAD 3D modeling application skills. So this table fan was divided into 4 components, which are the fan blade, the fan base, the fan stand, and also the fan guard respectively, among our all 4 members, and was reconstructed using the AutoCAD 3D modeling before we reassembled everything together. So for the objective of our project is actually to reverse engineer and also to understand the individual components of the table fan, as well as interpret, analyze, and regenerate the standardized 3D drawings in terms of accurate dimensions and all sorts.
Now, I'll be presenting about the component breakdown and descriptions. So firstly is the base and stand. The base and stand is the core backbone of the table fan. It supports the mechanics, motor, and electrical circuit, and it is the ground support for the fan positioning. Next is the fan blade. The fan blade is the main functional component that runs with the motor. It functions as the air circulation and movement booster, and it is slightly curved to create pressure difference in order to maximize airflow. And lastly is the fan guard. The fan guard function is to prevent accidental contacts and potential harm by the spinning blades, and it ensures the protection of the fan blades as to not disrupt.
Next, I'll be presenting the base part of our table fan design. For the 3D drawing, the base structure was created by using AutoCAD. The base functions as the support for the table fan and provides stability for the overall design. For the orthographic drawing, the base is represented in 3 different views, which are the front view, top view, and side view. These views show the exact shape and the dimensions of the base. From the top view, the base has a circular shape with a radius of 22 mm. From a front view, the overall width and length of the base are both 44 mm. From the side view, the height of the base is 6 mm, which show the thickness of the base structure.
Okay, next I'll be presenting the individual component which has been assigned to me, which is the fan stand. So here is the 3D drawing of the fan stand which I have modeled in AutoCAD. Then this is the orthographic drawing of the fan stand.
Next, I will be presenting the 3D drawing of the fan blade, which is the component I was responsible for. As you can see on this slide, we have displayed the 3D model using standard orthographic projections. Let's take a look on the 5-blade design. From the front view, we utilized a 5-blade configuration. This design was chosen to optimize airflow and maintain aerodynamic balance. So moving on this slide, here we have the detailed 2D AutoCAD orthographic drawing of the fan blade, complete with the exact dimension required for manufacturing. So there are 3 main points to highlight here. First is as shown in the front view, the maximum width of the blade span is 37.1 and the overall height is 35.93. There is also right side view. We can clearly see the total thickness, including the central hub, is 4.2. This compact profile is crucial for fitting into the main fan assembly. Drafting precision is also perfect to ensure absolute accuracy. You can see the construction lines and the 45-degree meter line in the top right quadrants.
This is our 3D drawing. It's created using the AutoCAD 3D modeling function. And this will be the protector for the fan blade to prevent any accidental touches and contacts, and also to keep the fan blade from external harm. So referring to the orthographic drawing, at the top left, it is a top view. So you can see that it has a diameter, a length of 50 mm, as well as 2.98 and 3.01 millimeters of thickness for 2 guards, the thickened guards at each side, And for the length of the guard lines, the guarded cage, it's 15 millimeters. And going down at the front view, you can see the rotational view of the guard cage. This is used using the function of array, and you can see the innermost circle, the darkened ones, we have a diameter of 14.74. It is a place where the fan blade will be will be attached to, and the second in circle is the radius of the tree, and also the radius of 25 at the outermost circle of the shell of the fan guard. Then moving to the bottom right, it is the side view of the fan guard. You can see the cage. It has a slight 2 millimeters difference from the thickened part of the cage, and then with the cage lines, and the total length, it's approximately 46 millimeters, and another 2 millimeters from each other on the connecting areas.
This is the 3D drawing developed by our group using AutoCAD. This model represents the overall design of the table fan, including fan blade, fan guard, fan stand, and fan base. Through this 3D model, our group was able to visualize the final design and the arrangement of each component. Next, I will explain the orthographic drawing of our table fan. The drawing consists of three main views, which are the front view, top view, and side view. These views are used to show the accurate shape and dimension of our design. For the front view, our group included the dimensions of fan guard, where the outer radius is 25mm and the inner radius is 22mm. The fan blade diameter is approximately 147.40mm, while the stand and the base dimensions are also included. For the side view, the overall height of our table fan is approximately 90.39mm with a base width of 44mm. This view also shows the position of the motor and the connection between the fan guard and the fan stand. For the top view, our group used this view to show the circular arrangement of the fan guard and the overall width of fan structure. Overall, the 3D drawing represents the appearance of our table fan design, while the orthographic drawing provides the technical details and dimensions to ensure the model is accurate.
The lessons that we've learned from conducting this 3D project together as a whole team is firstly, the AutoCAD techniques in 3D modeling fundamentals. Next is the video editing functions and techniques using CapCut. And lastly is the application of team working skills in the creation of a product model. In conclusion, a successful 3D project was executed among us as a whole group. The modeling was controlled with accurate dimensions and was assembled with logical constraints. Last but not least, the core principles of the usage of AutoCAD techniques were applied exquisitely. We as a whole group would like to say thank you to Dr. Shahir for giving your time and attention throughout our whole presentation for our 3D project. Thank you.